Hello everyone. In this question, it is asked that we are to find the complete set of real values of a for which the equation 9 raised to the power x minus 4a times 3 raised to the power x plus 4 minus a square equal to 0 has a unique root in the open interval 0 to 1. Okay, we are given an equation 9 raised to the power x minus 4a times 3 raised to the power x plus 4 minus a square equal to 0, and we are told that this equation has a unique root in the open interval 0 to 1, which implies that there is a value of x in this interval which satisfies this equation. Okay, so if I try to write this equation into a quadratic equation, then this becomes 3 to the power x whole square minus 4a times 3 to the power x plus 4 minus a square equal to 0. And if I write this 3 to the power x as y, then this becomes y square minus 4ay plus 4 minus a square equal to 0. Okay, and I have taken y equal to 3 to the power x, and it is given that since x is in this open interval 0 to 1, this implies that y, which is 3 to the power x, must belong in the open interval 3 raised to the power 0, which is 1, to 3 raised to the power 1, which is 3. Okay, so we are given that this has a unique root in this interval. Okay, so there are two possibilities of this. Let us look at them. We see the first inequality, first case, mm, which is that the root, only one root lies in this interval, and the other root, since it is a quadratic equation, this has two roots, the other root lies outside this interval. Okay, which means that roots are distinct. So in this case, the discriminant of this equation, quadratic equation, must be greater than 0. Okay, so if I write this as a function of y, this left hand side of this equation, okay, we have f of y equal to y square minus 4ay plus 4 minus a square. So in this case, in this case where there is only a single root and the roots are distinct and only single root is in the required interval, in this case, since this fy is a continuous function, and one root lies in this interval 1 to 3, therefore by intermediate value theorem this implies that the product of f of 1 times f of 3, this product will be less than 0, this product will be negative, right? So if I try to compute the values here of f of 1, this will become 1 minus 4a plus 4 minus a square. So this becomes 5 minus 4a minus a square, right? So if I try to take the minus common, this becomes a square plus 4a minus 5. So if I try to factorize it, this will become uh, a plus 5 times a minus 1. Okay, so if I take the minus inside this second bracket, this will become a plus 5 times 1 minus a, right? So I have found one value. Now let us find the value of f of 3. Okay. F of 3 will be equal to 3 square, which is 9, minus 4a times 3, so this will become minus 12a plus 4 minus a square. So this becomes 13 minus 12a minus a square. Again, if I take the minus common here, this becomes a square plus 12a minus 13. So this can be factorized as a plus 13 times a minus 1. So again, if I take the minus into the second factor, this becomes a plus 13 times 1 minus a. Okay, so now I can take this value, which is f of 1, and this value f of 3 in this. Okay, so this becomes a plus 5 times 1 minus a times a plus 13 times 1 minus a is less than 0. So now I get m 1 minus a whole square times a plus 5 times a plus 13 is less than 0. Now this first term is always going to be positive, right? This is a whole square. So we can eliminate this. This is always positive. So we have a plus 13. So if I write it as a minus of minus 13 times a minus of this plus 5 can be written as a minus of minus 5 less than 0. Okay. So this implies that a, since it is a strict inequality, this implies that a must belong in the open interval minus 13 to minus 5. Okay. This is the first case. This is the case where only one root is in this interval and the other root is outside this interval. Okay. There is another case where the two roots are identical, that is equal, and both of these roots which are identical lies in this interval. Okay, so let us look at that case. So the other case, both roots are equal and lie in this interval 1 to 3. So in this case the discriminant will be equal to 0. So the discriminant, which is y square minus 4ay plus 4 minus a square, equal to 0, right? So b square minus 4ac will be equal to 0. So this implies 4a whole square minus 4 times the equation was y square minus 4a y plus 4 minus a square. Okay, so coefficient a is 1 and c is 4 minus a square. This is equal to 0. So on solving this, this becomes 16 a square minus 16 plus 4 a square equal to 0. So this becomes 20 a square equal to 16. So this gives us a square equal to 4 upon 5. So this means a can take the value plus or minus, if I square root both sides, this becomes 2 upon root 5. Okay. So these are the two possible values of a. Now in this case, since the roots are repeated, okay, the root which is y, the repeated root will be minus b upon twice a, right? So minus b, the equation minus b is your minus of minus 4a times 2a. A is 1. Okay, coefficient of x y square, which is 1 in this case. So this becomes 2a. So this repeated root is y is equal to twice a. Now this y was in the interval open interval 1 to 3. Okay, so in this case it is given that y belongs to this interval, sorry, not 0, x was in this interval 0 to 1, y is in the interval open interval 1 to 3. Okay, so if I take the value, these two values, okay, this implies that y becomes plus minus 4 upon root 5, 2 times a, right? Now since y is in this interval, this is only taking positive values, so this implies that y cannot be equal to this minus 4 upon root 5 since it is in this interval. So this implies that a cannot take that value either. A also cannot be equal to minus 2 upon root 5, right? So we have to discard one value of a from this second case. So from the second case, we get the singular value that a can take this singular value of 2 upon root 5. Okay, so if I give this as 2 and this as 1, combining both, combining 1 and 2, we get a is in the interval minus 13 to minus 5 union the singular value of 2 upon square root 5. Okay, so this is the required final complete set of values which a can take, so that there is only a singular uh, unique root in this interval 0 to 1. Okay, so this was a bit lengthy and very interesting sum. Okay, if you have any doubts, you can write it in the comments, or if you think there is any mistake in any step, you can highlight it in the comments. Okay, I will try to rectify it further. Okay, thank you.